Great. So hi, everybody. My name is Andrew. I'm the Director of Finance with Manta Biofuel, where we produce cost-competitive renewable crude oil from algae. Next slide, Ben. So I think everybody on the call knows the problem at a broad basis. It's climate change, but to be more specific, we need a renewable liquid fuel solution in order to fully address climate change. There's a lot of parts of the economy, such as shipping, aviation, a lot of industrial applications that simply can't be powered with electricity and solar and wind at this point in time. So we need a renewable liquid fuel solution. And that's where Manta comes in. So today, Manta produces a renewable drop-in heating oil from algae for $75 per barrel. And at scale, we believe we can get to a carbon negative bio crude oil for less than $25 per barrel. Next slide, Ben. So we're a mission-driven company, and our mission is to sequester over 100 million metric tons of CO2 in the next decade. So yeah, next slide, Ben. You must be wondering how we intend to achieve such an audacious goal, and this really comes down obviously to the technology, which is at the root of it, but layer on top of that is a unique business model where we plan to create a marketplace between independent farmers and energy markets. So we will sell our equipment to the farmers. They'll use it to produce oil on their own land. Manta will then offtake it and match it with basically whoever needs it on the energy market side. As a result, we'll obviously reduce greenhouse gas emissions and collect carbon credits in addition. Next slide, Ben, please. So you must be wondering, how does the technology work? How are farmers going to use it? Just give me an overview. So here it is. It's 3 basic steps to take carbon out of the atmosphere and then convert it into a carbon neutral crude oil. So the first step is to grow the biomass. And we grow our biomass in a pretty unique way. We add another waste stream, chicken manure, to open ponds and let it grow between a few days and 2 weeks. Once the bloom is fully matured, it's ready to be harvested, which is where our technology comes in. We've developed a high throughput magnetic harvester to basically remove that algae from the water in a very cost-effective way. The difference between this solution and a lot of other ones is that it's very, very energy efficient because magnets are doing most of the work. And it's also extremely high throughput. So you can process millions and millions of liters with a pretty small, simple machine. And then the final step is converting that harvested biomass into a renewable crude oil. And we use a process called hydrothermal liquefaction to do that. And in order to do that, we've developed a low-cost reactor that can do that in a distributed manner. So these machines are actually located on the farm. Typically, when people are talking about conversion of biomass, it's done at a centralized facility such as ethanol plants. We think that this distributed kind of smaller scale model gives us much better economics and is also much more environmentally friendly because you're not driving the biomass back and forth from the farm to the production or to the conversion site. Next slide, Ben, please. So given that we have a two-sided marketplace business model, you must be asking, what's your value proposition to farmers? And we actually have a very good one, and that's rooted in part because of our technology, but also because algae is just a really amazing plant. So algae, just for starters, it grows, it can double its biomass every single day. So that would be like a plant. One day it's 2 feet, the next day it's 4 feet, and then the next day it's 8 feet high. If you saw a tree doing that, that'd be absolutely nuts. But that's what algae does, and so it gives you a very, very high productivity per acre, 4 times more so than corn and soy when you account for all the costs of harvesting and growing. In addition to that, our algae crop allows people to monetize unprofitable land. So there's a lot of non-arable land scattered throughout the country. And right now it's not being used for anything, but our algae can actually be grown on it because we don't need good soil. In addition, it gives you protection from bad weather, and it helps you diversify into new markets, all of which are very important for farmers who, globalization, a lot of like broad macro trends are kind of crunching their bottom line every single year. Next slide, Ben. And on the other side of that business model, the energy markets, I think the value proposition is a little bit clearer, but it's still worth reiterating. We're producing a product that's compatible with existing infrastructure, so it can be passed through a refinery, and the oil can then be refined into renewable diesel, jet fuel, gasoline, all different kinds of other hydrocarbon-based products. It doesn't require the users to change their experience or supply chain. So if you're getting oil delivered every Tuesday from your current heating oil dealer, we're going to do the same exact thing. Obviously, it allows you to be reduce your greenhouse gas emissions. but it also is cost competitive with fossil fuel. And that's kind of obviously the big thing that everybody talks about these days. The green premium is what's typically called, but in our situation, our product is actually cost competitive already. Next slide, Ben. So traction, this is where we've been since founding. We were started back in 2014. Over the first few years of the company, we were primarily grant funded. Most notably, we raised 2.2 million from the Department of Energy across 3 SBIRs. We've got a seed round ongoing right now where we've raised about 1.8, coming up on $1.9 million through crowdfunding and angels. We received a strategic investment from Exelon early this year, and we completed a 200-gallon test run with the University of Maryland in February. Next slide, Ben. So looking forward, we've got a lot of cool things in store for 2021, and we think that this is going to be like the year that we really tee up the commercialization story to raise a Series A in 2022. So I think the few that are really interesting to highlight, the most important, I guess, on the roadmap is the 10,000 gallons of heating oil. We intend to sell that to the University of Maryland later this year. Another couple interesting ones are on the harmful algae bloom remediation. And so summer's coming around. Down in Florida, they're already getting hit pretty hard with harmful algae blooms, specifically because of that, I think, wastewater kind of accident down there. It's really sparking it because of like the increased nutrient levels. But there's 2 companies and 2 angles that we're really gunning at here, AECOM and Solitude, to address this problem. So with Solitude, we're going to use our harvesting technology to remove algae from harmful algae blooms. We have a demo scheduled with them in August. And then on AECOM, they're interested in using our hydrothermal liquefaction reactor to convert algae that they harvest into a renewable crude oil product. Next slide, Ben. So just a few customer testimonials from across the state. So we've spoken with Sustainability Department, University of Maryland, and they called it a no-brainer to switch to our product. And it is really, because the fuel costs the same. There's no change to their day-to-day, the maintenance technicians' jobs and duties, and it generates a lot of positive PR and helps them meet their renewability goals. Homeowners also are very excited about switching because there's growing movement towards being more climate sensitive, just in the general public. Next slide. So I won't go too far into depth here, but we can chat about it in the Q&A. This is basically a survey of our IP. We've got a number of patents and trade secrets within the company that give us a very strong IP position for a company of our size. Next slide, Ben. So this is a demand market on the energy side. We have a phased, the big takeaway from the slide is that we have a phased market entry approach. So over the next couple of years, we're targeting the heating oil market, but then shortly after that intend to move into larger markets such as heavy oil and crude oil. Next slide. And here's our plan for scaling supply. So basically through 2023, Manta is going to be producing all the oil in-house. But then after that is when we start kicking in that two-sided marketplace business model I mentioned, where we're going to start selling our equipment across the country and scaling up independent producers. Next slide, please, Ben. So this is just a quick TAM, very high level, but I think it is a good illustration. The Department of Energy found that there's over 100 million acres of land that is suitable for algae biofuel. It means, it's got the water, it's close enough to the nutrients, it's got the right soil, I guess, in terms of like, it's flat and things like that. It's not infringing on farmland, on and on. They put it through the full battery. So there are 100 million acres. If you basically just back out productivity per acre, you can find that almost 2 gigatons of CO2 emissions can be prevented every single year by switching to algae biofuel production on that land. Next slide, Ben. So here's a quick high-level overview of our technology compared to people who have tried algae biofuels before. In a nutshell, our system is agriculture, and everybody else has tried it with pharmaceutical approach. And what I mean by that is we grow a polyculture. It's wild, it's nature, it comes from chicken manure, it's dirty, it's very low tech. Where we've really put our time and effort is on the downstream processing, making that able to basically process such a diverse feedstock. Other companies focus on getting like their super bug, a strain of algae that can grow ridiculously fast. But the problem with that is you have to build a very controlled environment around it. You can see in that second box on the bottom. Some people try to grow it in plastic bags. That doesn't look very environmentally friendly. And they also use very expensive techniques to dewater, so centrifuges and things like that. I already mentioned the centralized processing, but that's another thing that really weighs on the economics and the environmental footprint of the process. So we avoid all that by doing it all on farm in a low tech, simple way. Next slide, Ben. I think we're coming up on the end here. So here's the team founded by Ryan Powell back in 2014 out of his after his PhD at the University of Maryland, spun some technology out from there. We've got a team of 6 full-time right now across biology and engineering functions, and we've raised funding from all the organizations you see on the bottom there. Next slide, this will be about the use of funds. So as I mentioned, we've raised about 1.8, 1.9 million in the seed round over the past about 4 months. Next year, in the next 2 quarters or so, we're targeting a larger seed round to continue funding R&D and then build out the first chunk of our production site that'll be scaled up to eventually 300 acres. So I think that's the end of my presentation. Happy to engage in Q&A with anybody.